Hey, it's the very last test in the chapter, the root test. Very similar feel to the ratio test, but this one involves taking an nth root instead of doing a ratio. So here it is. For the series n equals 1 to infinity an, let's find the limit as n approaches infinity for the nth root of the absolute value of an. Now that seems like a weird thing to do. Turns out there's just really specific cases where the root test is going to be helpful. We'll see one of those in a moment. But okay, the nth root of the absolute value of n, if that equals L, and it's all the same three conclusions as the ratio test, right? If that limit L is less than 1, it converges absolutely. If it's greater than 1, the original diverges. If it equals 1, that's inconclusive. So the idea here, instead of taking a ratio, taking a root makes things, uh, you know, uh, I guess like the root, the nth root, um, as n goes to infinity, that's if you're taking very high degree roots, then that makes things smaller. And so if they shrink down to where it's less than 1, okay, but if it's still bigger than 1, oh man, these terms are blowing up, and equaling 1. Okay, inconclusive. All right, so that probably wasn't a very satisfactory explanation, but that's as much as I'm going to go into. So then let's get to our example. Converge or diverge? And here we go. And maybe after copying this, you start to understand, kind of the very specific types of series that we want to use this test for, the root test. Let's go with this one, from 2 to infinity, negative 1 to the n, the natural log of n raised to the n over e to the n. Like, wow, this is an awful nth term. I mean, natural log of n raised to the n and then all this other stuff. What do you notice about each piece? They're all to the nth power. Okay, so what if I was to take an nth root? All those would be gone. All right, so when everything is raised to the n power, then it makes sense to apply this test. So we'll take the nth root of the absolute value, and there I'll just copy that nth term. And what's going to happen? Well, it comes out really nice. The absolute value will get rid of the negative 1 to the n completely, you could say. And then the nth root takes care of the remaining n powers. And so all we're left with is the limit as n approaches infinity, natural log of n over e. Now that that power is gone on e, especially as n goes to infinity, well, this limit goes to infinity. Infinity, think, okay, if my answer is infinity, what does that mean? Well, it's all about 1, right? So if this is bigger than 1, then what does that mean for the original series? Do you know if your answer is, anything bigger than 1, let alone infinity, it diverges by the root test. I guess to be really clear, it doesn't diverge because it's infinity, it diverges because it's bigger than 1. So if it was 2, right, if that came out to be 2, it'd still diverge. All right, well, that is the last test. It's the last example here in 11.6. See you in the next one.